is that occupied by the snow caps of Mars, and over the whole of it the winter temperature must be far lower than the Earth minimum of minus 88 degrees Fahrenheit. Then, as the Martian summer comes on, there is less than half the sun heat available to raise this low temperature after a winter nearly double the length of ours. And when the summer does come with its scanty sun heat, that heat is not accumulated as it is by our dense and moisture-laden atmosphere, the marvelous effects of which we have already shown. Yet with all these adverse conditions, each assisting the other to produce a climate approximating to that which the Earth would have if it had no atmosphere, but retaining our superiority over Mars in receiving double the amount of sun heat, we are asked to accept a mean temperature for the more distant planet almost exactly the same as that of mild and equable southern England, and the disappearance of the vast snowfields of its polar regions as rapid and complete as what occurs with us. If the moon, even at its equator, had not its temperature raised above the freezing point of water, how can the more distant Mars, with its oblique noonday sun falling upon the snow caps, receive heat enough first to raise the temperature to 32 degrees Fahrenheit, and then to melt with marked rapidity the vast frozen plains of its polar regions? Mr. Lowell is, however, so regardless of the ordinary teachings of meteorological science that he actually accounts for the supposed mild climate of the polar regions of Mars by the absence of water on its surface and in its atmosphere. He concludes in his 5th chapter with the following words: "Could our Earth but get rid of its oceans, we too might have temperate regions stretching to the poles." Here he runs counter to two of the best established laws of terrestrial climatology: the wonderful equalizing effects of warm ocean currents, which are the chief agents in diminishing polar cold, the equally striking effects of warm moist winds derived from these oceans, and the great storehouse of heat we possess in our vapor-laden atmosphere, its vapor being primarily derived from these same oceans. But in Mr. Lowell's opinion, all our meteorologists are quite mistaken. Our oceans are our great drawbacks. Only get rid of them, and we should enjoy the exquisite climate of Mars, with its absence of clouds and fog, of rains or rivers, and its delightful expanses of perennial deserts, varied towards the pole by a scanty snowfall in winter, the melting of which might with great care supply us with the necessary moisture to grow wheat and cabbages for about 1/10, or more likely 1/100th, of our present population. I hope I may be excused for not treating such an argument seriously. The various considerations now advanced, especially those of which show the enormous cumulative and conservative effect of our dense and water-laden atmosphere, and the disastrous effect, judging from the actual condition of the moon, which the loss of it would have upon our temperature, seem to me quite sufficient to demonstrate important errors in the data, or fallacies in the complex mathematical argument by which Mr. Lowell has attempted to uphold his views as to the temperature and consequent climatic conditions of Mars. In concluding this portion of my discussion of the problem of Mars, I wish to call attention to the fact that my arguments, founded upon a comparison of the physical conditions of the Earth and Moon with those of Mars, is dependent on a small number of generally admitted scientific facts, while the conclusions drawn from those facts are simple and direct, requiring no mathematical knowledge to follow them or to appreciate their weight and cogency. I claim for them, therefore, that they are in no degree speculative, but in their data and methods exclusively scientific. In the next chapter, I will put forth a suggestion as to how the very curious markings upon the surface of Mars may possibly be interpreted, so as to be in harmony with the planet's actual physical condition and its not improbable origin and past history. Footnote 10. Keith Johnston's Africa in Stanford's Compendium. Footnote 11. Chambers Encyclopedia, article on deserts. Footnote 12. The effects of this cumulative power of a dense atmosphere are further discussed and illustrated in the last chapter of this book, where I show that the universal fact of steadily diminishing temperatures at higher altitudes is due solely to the diminution of this cumulative power of our atmosphere, and that from this cause alone the temperatures of Mars must be at that which would be found on a lofty plateau about 18,000 feet higher than the average peaks of the Andes. This concludes Chapter 6.